So we need to whittle these three equations with three unknowns down to two equations with two unknowns. So I'll take the first two and eliminate this z. So if I just add those first two guys as is together, I'll get 2x plus 2y, z's go away like I planned, equals 2. Then I need to do it again. So if I eliminated the z's the first time, got to do it again the second time. So I'm looking at equations 2 and 3. If I add those two together, that'll do it. So rewriting equation 2 and 3, I get x plus y minus z equals 2, and x minus y plus z equals 0. Adding these, I get 2x, those go away, and those go away, equals 2. Divide both sides by 2, and you get that x equals 1, which is very nice. So now if you just look at your little two equations with the two unknowns, you can just plug this x equals 1 into what we just did. So letting x equals 1, put that in here, it's 2 times 1 plus 2y equals 2. So 2 plus 2y equals 2. So 2y equals 0, because I subtracted 2 from both sides. Divide by 2, y would just equal 0. So now I've got x equals 1, y equals 0. Now I'll go all the way back up to any one of these original equations to figure out what that last z is. So remember, x was 1, y was 0. So putting it into this one, x was 1, y was 0. I don't know what z is yet. And so 1 plus z equals 0. So 1 plus z equals 0. So subtracting 1 from both sides, z would equal a negative 1. So we should have them all. X was a 1, y was a 0, and z was a negative 1. So that should be my answer. Let's check to make sure it works in all of these equations. So plugging in x is 1, 0, negative 1, that's x, y, and z, into each one of these, let's see if it works. So in the first one, x is 1, y is 0, z is negative 1, so 0 plus 0 minus 1 really does equal 0. That checks out. Plugging them into here, x was 1, y is 0, z is a negative 1, so 1 minus a minus 1 really does equal 2. That checks out. Plugging them into the last guy, x was 1, y was 0, z was a minus 1, so 1 minus 1 is 0. That checks out. So there is our ordered triplet.